In this video, we return to the presentation and discuss the primary and foreign keys. Again, if you took or are currently taking IDSC 3103 database class, this will be just a quick refresher. If you did not, don't worry. The concepts surrounding these two database keys are important to understand when working with databases that consist of multiple tables, which is virtually any database out there. The primary key is a field, or a combination of fields in case of order detailed table, as you'll see shortly, that uniquely identifies each record in a table. Customer ID uniquely identifies each customer, order ID each order, and the combination of order and product key uniquely identifies each order detail. Foreign key is a field in a table like order whose values match the primary key values in a related table like customer. Customer ID field in the order table is a foreign key because its values match the primary key customer ID values in the customer table. Customer ID is said to be the common field between the two related tables. The actual name of the field does not have to match, but the values and data types do. To distinguish between the two fields, they must be prefixed by the table names. So, order.customer ID is the customer ID foreign key field in the order table, while customer.customer ID is the customer ID primary key in the customer table. Foreign keys allow us to join two or more tables in a relational database and query them together to get the desired results. This slide explains the logic of joining two tables on the common field, which will translate into an inner join or simply join statement in the SQL code. That code statement goes something like customer inner join order on customer.customer ID equals order.customer ID. For more than two tables, the joins cascade typically from left to right, although the order is not terribly important. So to connect orders and products, one has to go through order details. Order inner join order detail on order.order_id equals order detail.order_id is executed first, and then the resulting join is again inner joined with product on order detail.product_id equals product.product_id. This particular set of joins will be used in the next slide when demonstrating the FRM cust orders functionality. So the functionality behind the FRM cust orders is slightly more complex when compared with the previous two forms, although lots of parts of it will be familiar to what we've done before. So to avoid some repetition and extensive code entry, I decided to just read through the code, explaining what it does, and run it at the end to demonstrate what it's supposed to achieve. So the objective is to list all the customers in the list box, storing customer ID in a value member property, just like we did before. Then we're going to use something called get cust order dates procedure, where we'll retrieve all the order dates for a selected customer. Most customers will not place multiple orders on a single day, and even if they did, we could get the repeated dates and would not know which one was which in that case. If we had the timestamp included in the order, which will certainly be the case for a more realistic order table, these would also be displayed, and display of multiple orders on the same day would not be an issue. So back to the order code. The next procedure is going to be get order products procedure that runs a query spanning order detail, and product tables using the exact same joins described on the previous slide. For the selected customer and order date, it will retrieve all the products going into that order, list their names and quantities, calculate the line item totals, display all that in the data grid view, and then calculate the overall order total in a separate text box at the bottom, as I'll show you shortly. Then every time a different customer and order date is selected, the corresponding order details and order total will be redisplayed and recalculated. There were a couple of issues with triggering of the list selection change events at the startup, which necessitated the check-in of legitimacy of customer IDs and order dates, but there was a minor technical issue that I believe was successfully resolved. So, switch back to the code, close the FRM cust city form and code, and then right click on cust orders to look at the designer first. So the two list boxes, one that's going to contain the list of all the customers, and then the other one that will contain the list of orders when a particular customer is selected, and then the product data grid view that acts as a shopping cart that will contain um, that will contain all the products that were shopped by that customer for that order, and then the order total will be calculated at the bottom. Okay, so to sort of walk through the code, we're going to right click and view it. Okay, and we'll start at the top. That contains the connection string as a class level variable, as it did with the previous FRM cust city example. We are loading all the tables except employee into respective data sets from the respective table adapters. So customer, order, product, and order detail table. So all of them are available in the code. Then we'll start by creating the query that is going to create the list of full names, and the customer IDs are going to be stored in that value member property. So they're in a sense not displayed as the full names are, and they're sort of hidden, and they'll be made available later on when we need those customer IDs. So the query is literally the same as it was in the customer age example, with this whole using the data adapter and data sets to fill the adapter to fill the data set, and then binding the data set to the list, and then displaying the full name, and then sort of just storing the customer ID for later. The get customer order dates was going to be called here initially for the initial customer, so that when the initial customer, the first one on top, is automatically selected, his or her order dates are listed here. Otherwise, every time the selected customer is changed in that list box over here, that same get customer orders procedure will be called. There's this, again, as I mentioned, the technical if to sort of avoid some of the problems I encountered when this event gets triggered before the customer IDs are assigned. It's not terribly important. It's more important to understand that the get customer order dates is selected every time a different customer is selected from the list. So this procedure has, again, a similar query that selects all the order dates from the order table, formatted in a particular way where the customer ID matches the one that was currently selected here. Okay, then again, the data adapter and data set scheme is executed, and the data set with all the order dates is then loaded into the second list here, right, for the selected customer. Okay, then once the selection of a date in the list of order dates is made/changed, okay, after again checking for the legitimacy of the dates, we're going to call the procedure that will get us all the order products for that particular customer and for that particular date. Okay, so this is the procedure that has a more complicated query that selects a product name, quantity, retail price, and quantity is multiplied to get the line total from a inner join between the order and order detail on the order ID between the two tables, which is then inner joined with the product ID between order detail and product. So that's the more complicated query spanning three table: order detail, and product, where the customer ID is the customer ID from the customer list box, and the order date is simply the text that from their orders list. Then simply converted to a date with the pound signs around it. Okay, then again, the data adapter and data set are created, to execute that query and fill the data set, and then the data set and its table are then loaded into the or displayed, I should say, in a data grid view, which is formatted appropriately. You can kind of take a look at this. The widths, the cell alignments, not big deal. Just makes it look better. And then, just like in the, I believe it was customer age example, we are similarly to the customer age example. We are sort of looping through all the products in that particular order and adding up the third column, which you may recall here. This is the first one, this is the second one, the third one is line total, which is then adding all the line totals and displaying the total order in that text box. Okay, so that's as you can see, slightly more complicated functionality. Has several objects and events associated with them, from form load to changing the customer selection and getting the order dates, to then changing the order selection and then getting the product for the combination of the customer and the order. All right, so if we make sure that customer orders form is the startup form, let's see if it runs. So it gets us for the first default customer. Gary here has or had two orders, one on April 24th, 25 for football jersey, two of them for the total of 159, line total 159, which is also the order total, and then one on July 21st for the jersey, two jerseys and the football, which then added up to 172. And then if you change the customer for, let's say, I think Sean here had a bunch of orders. Yep, you can see how that dynamically changes, right? The orders for Sean, and then the orders automatically, as you select a new customer, it's going to pick the first order and display the details over here in the order total. Okay, so it's quite nice functionality that has this dynamic within customers' orders, and then order details and products displayed. Okay, so let's get back to the presentation. Okay, and before we go to the last demonstration of the order entry form, we will take a pause.